Okay, so today I'm going to walk through a tutorial on how I use Faro SCENE to put together terrestrial laser scans um, in different forest environments. So the first step is getting SCENE on your computer. I ended up downloading a trial version of the newest version so that I could do this tutorial. But the first thing that I would suggest doing, this is a personal preference of mine, but to switch to this kind of older interface, this is what I'm used to. But you can click this button here, and it'll switch to this kind of more, kind of a newer looking project workflow interface. But that really isn't my preference, in part because I feel like you have a little bit more versatility in the older original interface, those used for the software. So you can click that button and switch to this interface so that you can follow along. Again, this is the trial version. The version seems to be 2022 1.0. Now, the first thing that you're going to need to do is find your laser scan files. I'm doing this for a collaboration with some folks, and whether the files are actually in the scanner memory card or on a on a hard drive or your machine or something, they'll all come as this folder with a .fls file type. And so bringing them into SCENE is actually fairly simple. You just highlight those that are all from the same plot, and you can drag them directly in. Now, before we move any further, I think it's really important that we change a couple settings around within the software to make sure that we're not losing data that we might need. This is something that is kind of specific to working in forests with this type of software, where you need to ensure that things are not over filtered, basically. So if we go into options and then click default filter, by default this checkbox is clicked, and it gives you some options for filters. This is a filter based on kind of basically the brightness or the reflectance that the scanner detects. And then this is a grid-based filter that I have some like custom settings for these. You're welcome to give these a try, but also fiddle with them depending on your type of environment and what seems to work for you. However, I always turn this off because I think filtering is something that needs to be really fine-tuned. So to ensure that you keep absolutely everything that you have collected with the laser scanner, you need to turn that filter off. The other thing that you can do in this option setting is you can select the kind of automatic sphere size that might be in the field with you. So if you are out in say in the forest and you have a certain size sphere that you're using for registration, you can input the radius of those specific sphere size in here, and that will allow you to automatically identify those spheres. However, for this project, I'm not sure exactly what sphere size they use, so I'm not going to actually put anything in there. You can hit apply so that those settings go through. Okay. And now you can start looking at your scans. So the very first scan, what I tend to do is I go in and right click, hit view, planar view. And this gives you kind of an idea of the site that you're looking at. You'll always get this error when you turn off that default filter, but I think you kind of have to just deal with that for the sake of this type of processing, in part because the default filters tend to over filter scans in really complex environments like forests. So hit OK, be okay with it, and then you can look through the scan. Right now, I have the images colored by range and the invalid points colored by this magenta color. That's another thing that you can change. I'll turn this off with this little button here. If the filter settings are turned off on the laser scanner, there will be no magenta color here. That would be ideal because all of the filtering that's available on the laser scanner is also available within the software. So I would tend to recommend people not use those filters on the scanner because you never know what will work and what will not work in certain environments. For visualization, I just wanted to show that in this view panel, I think it's one thing you might want to do is change the max distance so that it will color to, kind of a realistic distance. Let's say 60 meters in this case. Also, I always like to have these invalid points colored, so I'll select that as well. So hit apply, OK, and now we could turn that back on and everything should have a color now, basically. Okay, if we use our mouse and we kind of scroll back, we can look at the entire kind of cylindrical projection of this laser scanner image. This is like a depth field, basically. All of these magenta, again, these are sky points, and this is what you want to see under like a default filter setting that we removed initially. A lot more would be filtered out, and that's not ideal, I'd say. So then the other thing that I find useful, just to get an idea of how much is actually being filtered out, you can also remove the range colors. So if we go back to options and view, deselect color coded distances, apply, OK, and then we can click this button again. Sometimes it takes a couple times to kick in, I believe. Well, under normal circumstances, when you deselect that and hit apply, let's hit it a couple times, see what happens. Hit that a couple times. You never know. Okay. Huh. Well, I guess that's something you can play with to try to get it to work. Under with other versions of the software, this has not been an issue, but it is nice because then you can, or actually, you know what? I have a little workaround that I can do. We can change the max distance to like, I don't know, 0.5 meters or something. Then we'll just see what's really close to us. There we go. Okay, so if you can't get yours to work, you can do that. So this really kind of reveals how much is being filtered, and while this would probably be great for something like individual tree modeling that you can use down the pipeline. This is not at all what you would want to see for any sort of estimates of foliage profiles or things like that. So I would suggest with these types of laser scanners to make sure that all the filters are off on the laser scanner so that you can get good estimates of the gaps in the canopy, which are basically how we tend to estimate LAI or plant area index using laser scanners. So with that, we can actually move on, and I'll turn this off, and we can just kind of look at the data we have here. So the first thing that I tend to do in processing these types of data to basically find all your registration points, and I think realistically this is something that is best done with these spheres for the Faro, but in this case we have these panels here, which are fairly easy to identify and can be used for registration. So I'll just give you an example of how you might kind of narrow in on those so that you can use them for registration. So let's click this mark checkerboard target and just click in the center, and it will identify that. Then you just want to kind of go through the scan and find the rest of those checkerboard targets. That one didn't turn out so well. Anyway, mark this one really quick. We have another. I just want to reiterate that the best type of registration object is something that you can see from all positions and looks the same basically from all your different scan positions. So I actually almost never use these checkerboard targets, but we can see what we can do with them. All right, so once we have those selected, basically what we want to do is I'm going to try this. This is my typical workflow where I click this, it's like a 1-2 pane. And the idea here is to kind of start your registration process by pulling in your first scan and then your second scan. So let's pull in our second scan, and then let the scan load in. Again, we'll get that filter notification, and hopefully as we mark additional targets, it should automatically recognize the position of some of these such that the registration ends up going pretty fast. So I'll select the mark checkerboard target again, and let's see what we can find. Here's another flat panel from a checkerboard target, but there you go. It says insufficient number of points. So that's something you got to watch out for, and that's one reason why the spheres tend to work quite a bit better. But that's no worries. We can just kind of go around and look for other positions with these targets, and hopefully we can get enough. Okay, here's another. I see one here. Not perfect, but again, we'll have to see what comes together. Ah, this is a very exciting point in the registration process. So once you have as many marked as possible, looks like there's one over here as well. Usually, if you kind of know where you are, you can manually force the correspondence, or you can try to find the correspondence between the two scans. So we're going to click this button and see if it works. If it doesn't work, then we'll have to figure out how to do this manually. Seems like it doesn't want to work. That's cool. So in that case, what we can do is we can kind of zoom out and get an idea of kind of where we are. That's always kind of the approach I take. I try to find features that are unique within the scans. So zoom out and see if I can see anything that corresponds between the two, and then you can kind of start to piece it together. Like one example I see here is there's like near the targets you might find, wow, this is actually a pretty challenging location, and with the checkerboard targets it's pretty nuts. So let me see, maybe there's something obvious around here. I don't know. Alright, well, so if that doesn't work, there's a whole other way that you can approach this too. So now that we've marked the checkerboard targets, in this case preferably spheres if you're planning ahead, you can open this correspondence view, and we're going to try something. You always should only have like 2 scans loaded at the same time. It's going to automatically try to load everything in, which is kind of annoying, but you have to wait for just a second for it to do that. Okay, so once all those scans are loaded, it appears some of the rough positions of the laser scanner are in there, and part of that is, I believe, because these have GPS on board. But what we want to do is actually make those disappear, and then we have just the 2. And what you can do is you can go in and try to find the match checkerboard targets. So let's see if we can do it. So the first step is I tend to just treat the center scan as the truth, because that kind of helps us get our bearings, and then you can kind of see it's having a hard time showing this clearly, partially because I'm working on a remote desktop. So then you can grab this kind of set of arrows here, and you can kind of roughly see the location of of your checkerboard targets that you selected, and then you just want to kind of try to find where they should be. So what I see here is that I see at least 3 that are definitely the same. So I'm going to put them next to each other and kind of zoom in, and then I'm going to try to lock their like correspondence to each other. So here we go. Let's see if I can do it. It's lagging a lot, which is kind of a bummer, but there we go. You can see 2 in here, which is actually kind of nice. So what I'll do is now I will force correspondence, then you click these, 1, and then the next one. Now those are going to be linked. Whoa. Hopefully. Let's go with that one. Okay, and now that I have another, I click that, and click that. Okay, and now those are linked. You can't really do much with only 2 that are aligned, so we need a third one. So let's zoom out again and move over to the right, where we can see there's one other set here that we were able to find. And we can zoom in and do it again. And then once we have 3, that should be enough to do this registration. So click it, click the next one. Those should be locked, and you can tell the correspondences are kind of the forced correspondences are there because there should be a C right next to these little icons on the side. So now if we close out of this and go back to this, you'll see that these now appear to be linked. So now we're going to force the correspondences between the scans, and in scans, in the scans folder, we go to registration, place scans. We're going to turn off enable correspondence search because we already did that, and I tend to turn this target distribution threshold thing down to badly distributed because the kind of criteria in, like, say, architectural work with laser scanning is very different than what it is in a forest, where there's a lot of kind of uncertainty and noise inherently. And then let's see what we get. Oh, also, yes, we can use all this stuff. Since there's GPS on board, that's great. We can use that. Compass, inclinometer, also good. And then just hit OK. See what happens. Okay. So this is what will happen under most situations where, actually what I can do, most situations where you have other scans that are included that have not been included in the registration. So in this case, let's see, we can go to the correspondence view and we can see how well they kind of match up. Hit OK there. And then we can get an idea of, like, okay, did those points actually like line up correctly? If they didn't, you kind of have to iterate over this a bit. And I will say, like, I just want to say again that had this been with spheres, the results and the alignment and everything between these two scans would probably be a whole lot better. But, you work with what you work with. Maybe I can upload another example of registration with spheres. But I think that's pretty good given what we're working with. And so we can, zoom in and check out how the scans align. This is a really important piece of doing this kind of registration. You have to look at what you've done. You can't just trust that the automatic algorithms and everything actually worked. So this is a good sign, coming in, and you can kind of see one side of a tree trunk is red, the other is green in this case, and it actually seems to have filled it out nicely. I'm sure the alignment is not perfect, but for the sake of this tutorial and for the sake of time, I think I'll leave it at that. Once that's been done, you basically just continue on with each subsequent scan. So now what I would usually do is I would go into these scans, go back into our split view, and keep the the center scan visible, and then drag in I would keep the center scan on one of them and drag in the one scan that's not registered, which is for some reason being weird. All right. And then once you have the new scan in here, you can go through the same process where you just select the spheres or the checkerboards, and once it's all aligned and everything, I can show you really quick. You don't have to necessarily be in that correspondence view. You can go to the full kind of 3D view, and this allows you to kind of explore it. Again, I would suggest going through and trying out filters that might be helpful in getting rid of some of this noise. There's always going to be noise in this type of data, and that's something you can fine-tune. You can try out the filter that I suggested before. But if I were to do that, I can show you really quick. Again, you select that kind of cluster of scans here, and then operations, filter. Whoa. Maybe in pre-process. They've moved a couple things around in the newer version, so I guess we'll just this will be the first save. Okay, now that it has saved, we can go through and look at a couple of these filters that we might use. The first thing is this dark scan point filter. So the way that I kind of evaluate whether or not you want to use that and what the threshold should be, we'll just go into the first scan and click View, Planar View. And what you kind of want to do here is you want to look to see, actually one thing that can be very helpful here is turning the range on, because at a certain point when the returns from the laser are not very strong, there's a lot of uncertainty in what the range is. So what I'm going to do is kind of just show how you can go about, let's limit our distance kind of range to, I don't know, 50 to 80 meters, which I think is like beyond what this laser scanner can actually officially detect, but it gets returns way out there. So here we go. You can see a couple places where the laser scanner found stuff out that far. So all of that, is going to end up being pretty noisy out there. And then what you can do is, depending on where you are in all this, you can look and see what the reflectance is. And the reflectance is this RF number here. And sometimes this method doesn't always correspond or work with this like dark scan filter idea. So these are actually all pretty surprisingly bright, but you could like find this pixel here that's like a black looking pixel. Just seeing what these kind of reflectance values are. If you look in the sky, you can clearly see, again, bottom right corner, what that number is, and it's going to be very low. So the reflectance filter actually might do virtually nothing in this case. And so I think I'll skip that, or we can add it just at a very low value to get a couple of, stray or whatever things. I'm unfamiliar with this edge artifact filter, but it sounds like that would be pretty useful, especially because that tends to be where a lot of noise comes in this laser scanning data on phase shift scanners. For this stray scan point filter, I can just show you roughly the settings that I tend to use. The grid size I keep as small as possible. That limits the filtering quite a bit. And then the distance threshold is like the threshold away from an object in that grid for which it'll be removed. So this keeps it pretty tight. However, if you keep this allocation threshold really low, it doesn't tend to over filter as much. So 10% for that. Seems like these have, it's saying apply pictures, so maybe they have pictures included. I'm not sure, but that's going to take a lot longer. So I'm going to deselect all this extra stuff. I'm going to hit OK, and we can see kind of what it ends up looking like after those filters go through. Most likely what we will see is all these magenta colors will come out even more. Some of these clusters of leaves will become like separated, around the edges, and that's not a big issue with any sort of quantitative structural modeling, but again, the workflow and everything is really different for something like reconstructing foliage profiles and things like that. So again, I would really strongly recommend turning off the filtering settings on the laser scanner so that you can keep all of those points to get good estimates of gap probability. Okay, so looks like the filter finished. I'm gonna close everything else out here, and then we can reload it and hopefully see what the filtered laser scans look like with that different stray filter. It's taking its sweet time to load, and we'll do view, 3D view, and maybe it'll look a little bit better. And turn it on its side. Yeah, so I mean, I'm seeing that it seems to have improved some areas in here. Another thing we can do to kind of like look at this is we can add this like clear view, which I don't know how well that'll show up on a remote desktop, but that can be useful in just kind of getting an idea of what the laser scanner data looks like. And then let's see about, all right, here we go. So that actually looks pretty good as far as I can tell. A lot of the noise seems to be kind of not as bad, but yeah, so that's kind of the process with filtering. Again, we only have 2 scans. As we add in the remaining 3, it should actually get quite a bit better. So it's asking me to save these pre-processed scans, and then I'll just quickly show you how you can export the data. Because once you align and register everything, you basically want to get out of Scene as soon as possible, so that you can do kind of further processing of these data. So I'm going to export scans here, and I tend to your export format again will depend on what your purpose and applications are. The last time I was using Scene, LAS was actually not an option to export point clouds in, but that tends to be a preferred LiDAR format for a lot of folks. For more raw data formats, like if I'm going to be exporting for estimates of foliage profiles, I'll choose this PTX format, which is nice because it includes all of the pulse information, rows and columns that are in the scan file. XYZ, again, is another real simple ASCII, basically long form data format that is useful. And then some people like E57. There really isn't any solid convention with terrestrial laser scanning data in terms of like what the file format is. But for this, because I've never actually seen what last file looks like exported to or from scene, we'll just do that for fun and see what happens. Name it something, test scan. There's scans. There are 2 in here. Okay. And the other thing that I'll mention is with some of these formats, you can export the scans individually, and sometimes that is preferable. So with XYZ, you can export each scan into a separate file, and that can be nice for lots of reasons. But again, I'm curious about LAS, so let's export as that file format. And since there are only 2 scans here, this shouldn't take too long. And while that is exporting, I'm going to open up Cloud Compare just to show you that, if everything goes according to plan, we should be able to just drag that last file or open that last file up in Cloud Compare, which is open source software, which I strongly recommend always using as much open source software as possible. And we can go to our desktop and try to find a last file. Okay, so it automatically exported those into 2 separate files, which is nice. Hopefully they have the position information included, in which case that would be really useful, because then our registration will stay. I guess apply all. Yes, to all in this case, but let's not. It's just because I'm not going to overthink that, just for the visualization purpose here. But yeah, it looks like it's loading in fine, and we'll be able to look at it in just a moment. I'll make this window a little larger so you can see what's happening. Ooh, all right. So one loaded in. And you can click it and check out, we have our scalar fields, which in this case I believe is just going to be the intensity information. If you had photos that you'd collected in the field, they would be in this drop-down menu as RGB values. So it looks like they are aligned, which is great. So once we have it in Cloud Compare, it's actually nice because I feel like it kind of gives you a more truthful picture of how well everything worked out in your other in your kind of registration process. But yeah, seems like everything worked well, and that should be all you need to know to be able to do, the full workflow of registration, from, basically importing raw laser scanning data into Faro SCENE in kind of forest environment, the filters you need, doing correspondence or registration, selecting all those registration points, bringing them together in what I would say is a more difficult version of registration than I typically go through, and filtering, exporting, and visualizing in in another software, Cloud Compare in this case. So yeah, I guess if you have any questions, let me know, hit me up, and I can try to provide some more information on how I do this process if any questions come up. Thanks for hanging out and listening.